Hello, welcome to yet another video on SRAD Cloud. In this video, I want to talk about the source code version control management tool called Git. So let's get started. When you write a piece of software spanning across multiple files, you will certainly want to combine them together into a version. So you can refer to a feature or bug in that software with reference to that particular version. It is easy to do it that way. And a specific version is often associated to a corresponding release of the software. Like Git allows you to manage all these very efficiently. In Git, a released version corresponds to an entity called branch. So more on this later in a few minutes when I demonstrate all these things. So if you are the only developer in the software development group, which is not the case most of the time, you can keep various versions of the software you are developing in folders locally on your computer. But what if multiple team members are involved in your team, which is the case most of the time? So you need a central repository to keep the files for the software and manage their versions somehow. So a tool like Git is there to accomplish this very critical requirement for version control, and it needs to support distributed nature of access. So Git allows you not just retrieve part of the source code, but also clone the entire repository to a local directory. And you can make necessary modifications, and after you're happy with all the changes, you can push the changes back into the central repository. So I'll walk you through all these things in a simple such process in a few minutes. But the advantage of this approach is to let you focus and work on your changes offline after cloning the entire repository. So when you're ready, you need to be online and push your changes back. It's very convenient that way. So in a version control system, a different version of the files can be stored in two different ways in general. So one way, along with the original file of the first version, only differences can be stored separately for subsequent versions. So to construct a file for a specific version, you need to start with the original file and then keep playing the differences over and over again until you reach the desired version. So this may sound very easy, but it is not very efficient. So Git does not do version management this way. For every change, a bunch of files to a bunch of files in a specific what is called a commit, a snapshot of the file system under the root directory is taken and it is stored. So a snapshot will contain only the modified files to keep the file system as small as possible. And when you clone a repository from a central location to a local directory, all snapshots are downloaded and made available locally. So this is how you can fully work on changes to files locally and offline as well. So GitHub can be accessed through a web interface, and you can also access it through a command line interface. So I'm going to show you how to do both in this video. So at a very high level, the repository is on the github.com, and you have to clone it to work on it. And then you make some changes and you create a branch. And then if you're happy with it, you can commit those changes, and then you can push them back into the centralized repository. I'm going to show you how to do those things in this video. And GitHub also has this concept of upstream, downstream repositories, and a concept called forking. A process of forking will involve copying or cloning the entire repository from one account to another account. So why do we need this? In open source community, the source code can easily become corrupt or dirty because there are so many people involved. And if you let everyone come in and make changes directly, then bugs can creep in, and the management of such a repository will become very, very difficult. So the methodology used is to fork a particular repository into your account, and then you clone it into your workstation, and then you create a branch, and then you make all the necessary changes. And when you're happy, you can push the changes back into the upstream repository, the original repository from where you forked the changes. I'm going to show you all these things in this video. So this helps to keep the management of the source code at a very, very efficient level. So now let's get started. Let us go and create a repository. So as I said earlier, you can use either a command line interface or you can use the web interface to create a repository. Let us look at both of them. So first of all, you need to log in to the github.com. You should have an account, and I'm not going to cover how to create an account and all that. Should be very self-explanatory on github.com. So once you log in, you can go to the repositories page and you can create a repository. Or alternatively, if you want to do it through command line interface, which probably required if you want to work on automation and DevOps and all that, you can use the curl command as shown in this page to create a repository. So once you key in this command line, curl -u, and then your user ID to the github.com, and then the URL of the github.com API repositories, and provide a name for your repository. In this case, my repository is the name. And when you hit enter, it is going to prompt you for the password. If you enabled two-stage authentication, then you will have to enter the token. And then the repository will be created in the backend. So now let's take a look at the UI approach on how to create the repository through a browser interface. So I'm logged in, and I'm going to create a new repository. I had to switch to the repositories section, and then click on new repository. And I can give a meaningful repository name like my demo repository, and I can provide a description. And I want this repository to be a public so that anybody can look at the source code, look at everything in this repository, and also clone it, fork it, whatever. And then I'm going to add a README file, and that's it. Just create repository. And remember, you can do the same thing using the curl command that I mentioned earlier. So this is the browser equivalent. So now the repository is ready, and a file called readme.md is also created, and I can see it. So now, to keep things simple, I can make a change to this readme.md, or I can even add a new file to this repository, all in this browser interface, and I can commit such a change, and I can even push it and make it permanent. So that is an option, but that is not very useful. You don't want to do everything in this browser interface. You cannot. So we are going to install what is called a Git client on my operating system. It can be a Windows, it can be Mac, or it can be Linux. And I can clone this repository, and I can make changes, and I can commit them, and then I can push them back into this repository as well. So let us see how those things are done now. So now let me make the change directly on the browser. So I'm going to click on this readme.md file, and then click on this button to edit it. And I can add a new line. So I added a line to this readme.md file, and I can commit these changes. If I want, I can provide a meaningful name for this commit and also a description for it, and then click on commit changes. So now the changes are done, and you can see the new line is now made permanent in this file. Now, how to do the same thing using command line? That's what we're going to see next. I'm going to use a Red Hat Linux operating system. I'm going to be using the RHEL 8 for this work. Let me maximize it a little bit. So here I already installed Git. So otherwise I need to do yum install Git, or I can say dnf install Git. So I already done that, and so Git program is now available. So the first thing, I would like to clone the repository. So for that I need the repository's URL. So I need to get back to the web interface. So on my web interface, under this repository that I just created, I click on this code button and copy the URL to clipboard. And this is what I'm going to clone in my Git client. So now let me clone the repository. And hit enter. So now the repository got downloaded. You can see a directory called my demo repository. And the only file in this repository is readme.md. Let me take a look at it. And it contains the original line. This is a demonstration repository. And it also contains the newly added line as well. So we cloned the repository, and we also looked at the files and the changes and so on. So now the next step is to look at the Git status. So now let's do that. So Git status tells that there are no additional changes and everything is clean, and now it is ready for me to make some changes. And let me show you a couple other command line tools that will help us in the next few steps. First of all, the branches. So let me say git branch, and it says main is the only branch. So main is the branch that is created for me to make some changes, but I will not do that. I will always create a new branch and make my changes. That's the best practice. And another concept that I would like to show you is the remote. So git remote shows the origin as the remote. So this origin represents the repository from where I cloned this repository. And here is the URL for downloading files from the repository, the fetch. And the second one is the repository URL for me to push changes back. And both are identical in this case. And later on, I will be creating additional remotes, and the need for it will be explained later. So now let's move on to modify a file and then see how it can be pushed back into the repository. So first of all, let me do git status, and it shows everything is clean. And The only file that we have is read.md. So let me modify that file. Remember, we did the same thing using the browser directly, but this approach is more efficient. You can do it from your workstation. I'm going to add one more line. This is line added using CLI. So now if I do git status, it will show me the status of the repository on this local workspace. It says the readme.md is modified. And this readme.md file change needs to be committed before I can push it back into the central repository. So to do that, it even suggests what I should do. It says git add. So that's exactly what I'm going to do now. I will say git add, and I generally add the current directory, the dot, so that any file that got changed under any subdirectory will be added automatically. I don't have to do the git add separately one by one. So now the changes are committed, or rather they are added to the staging area. Now it says this particular file is now in the staging area. So now the next step for me is to commit this change, and that is done with this command git commit -a. It opens up a VI editor, and in this editor the general practice is to add a title. Many GitHub repositories demand that you keep the title for only up to 80 characters, and some of them extend up to 130 characters. So always refer to the policies of the GitHub repository that you're working with. And then you generally need to enter a description. And you can do it in multiple lines into a paragraph. And in some GitHub repositories, the policy is to key in the case number in case if you are fixing a bug. Like that. So these are required if your repository demands them, otherwise you don't have to. So now I'm going to save it and quit. Now the changes are now committed, but looks like there are certain things are missing in this configuration of the Git. So I need to take care of them first. So as suggested by the GitHub client itself, I need to run git config global edit. And when I'm done, I can enter this command git commit --amend --reset author. Let us talk about this amend in few minutes because that is very, very important. So now let me do git config edit. So now I need to enter a user. So the name of the user in my case is gitsridhar, and my email is saradiapple@gmail.com. So now let me save it. Now I can perform git commit --amend reset author. So this amend is very, very interesting and very important to know. Let us say, for example, you committed and you pushed the change into the repository, and then you want to do it again, and you either clone the entire repository again, or you can maintain the same cloned repository on your local workstation, and you can make some additional changes to the source code, and then you stage them into staging area with the git add command, and then you perform git commit command, and then before you push, you would like to do one more commit. Let us say, for example, you committed the changes and then you performed some unit tests or code verification, code review and all that, and they found a problem. And before pushing, you would like to commit again, make some changes and commit again. Then you will use the amend parameter. So amend parameter is required if you want to perform multiple commits before pushing the code changes. So that is exactly what happened here. I committed and that gave me a problem, and I fixed it by adding my ID and email ID. And then now I'm going to commit again with amend parameter. When I do that, the same thing I entered in the previous commit will be preserved and presented. I'm not going to make any changes. I'm just going to quit, and now the files are changed. So now if I do git status, I can see that there is nothing else to be committed. Everything in the staging area is in committed state. And now I need to do git push to push the file changes back into the repository. So that's exactly what I'm going to do now. Git push. And it's asking me for the user ID and password because I'm doing it for the first time in this repository. Let me do those things. Yeah, so I keyed in my user ID and password, and the file got pushed into the repository on the github.com. Now if I do git status, I should see everything is perfect, everything is clean. So now let us go back to the web interface and see if the change I made from the command line interface is reflected there. So I am in the repository on the github.com, and let me refresh it. You can see the additional line that I added using CLI. And let us take a look at this file readme.md one more time. And it contains the commit ID, the latest commit that I performed 3 minutes ago. I can also click on the history to see what all I did. There was an initial commit a few minutes ago, and then I made this update readme.md directly on the browser, and then I made one more change from the CLI. So these are the different commits made to this particular file. So like that, you can take a look at the history of any file and understand what all got changed by various players, team members to that file. So this should give you an overview of what exactly happens when you create a repository on the browser interface, or you can do it through CLI as well, and then you can clone it to your workstation, Mac or Linux or Windows, and then make some changes, and then you add the file changes to the staging area, and then you can commit them with a message with the title and description and so on, and you will get an opportunity to key in additional information about the changes, like the bug ID or the defect that you are fixing with this change and so on, and then you can push the change back into the repository. Once a file is pushed into the repository, other team members can clone or pull your changes into their local interface and start working on further and so on. So to recap, we added files after cloning the repository, and the files got added to the staging area when we did that, and they are all ready to for the commit process. And then we performed commit. The commit moved the files to the committed area. And then we performed push. And when we did that, the file changes got moved back into the GitHub repository on the cloud. So now the next thing to learn about is branches. So what exactly is a branch? Let us find out. So I never would like to change the master branch or the main branch directly. Why? In a team environment, I want my changes always to be reviewed by somebody. So in GitHub, there's a concept called pull request. So I need to create a new branch, and then I need to make some changes in that branch only without touching the master or main branch. And then I need to add that change to a staging area and then commit it and then push it. And when I do the push, the GitHub will not let me to put the change directly into the main or master branch. It will prompt me to create what is called a pull request. A pull request, when it is created, is ready for review. And other team members can review the changes. And in some GitHub repositories, a policy is set in place to make sure at least 2 reviewers review your code. And in some, no reviewers, nothing. So that is also possible. Then when the review is complete, you can click on a button to merge the changes from the branch that you created into the main or master branch. So let us see how that is done. So now I'm going to create a new branch. This is the same repository where I did the earlier work. So git status says everything is fine. I'm going to say git checkout -b branch 2. So I'm creating a new branch called branch 2. So that is my current branch. If I do git branch, it will say branch 2 is the current branch. The branch 1 that you see was already created for something else previously. So branch 2 is my current branch. Then now I will go and make a change to the README file under the branch 2 only. I can say this is changed with branch 2. So now, as we did earlier, I need to perform git add. Before that, let me do git status. It says the file readme.md is modified. So let me do git add dot. Now let me do git status again. It says this file is ready to be committed. It is in the staging area. So I will say git commit -a, exactly similar to what I did before. And I'm not using the amend parameter here because this is the first commit for this change. And here I will say this is for branch 2. This change is for branch demonstration, and so on. So now the file is ready to be pushed. Remember, I am still in branch 2. There is no such thing called branch 2 in the GitHub repository on the GitHub web page. So I need to somehow create this branch 2 as well. But let me try this. Let me try git push anyway and see what happens. It says there is no such thing called branch 2 in the GitHub. So I need to perform git push set upstream origin branch 2. When I do this, the changes will not only be pushed, it will also be pushed under branch 2 branch. A new branch will be created automatically. So let me key in my user ID and password. Let me do this again. Now the changes are getting pushed and pushed successfully. Now let me switch over to the web interface and see whether I can locate the second branch and also the changes, and also, as I described earlier, how to create a pull request and, if approved or when it is approved, merge it back into the main branch. So here is my web interface, and automatically a message appears that branch 2 has recently has a recent push a minute ago. So here is the button that says compare and pull request. This is how you create a pull request on the GitHub page. And everything I entered during the git commit are repeated here. And I just say create pull request, and a pull request got created. And if I want, I can add some reviewers here and ask them to review these changes that I made. And if everyone is happy, you will see the entire conversation here. The questions from the reviewers to you and your answers to them and so on. After the conversation completes successfully, the reviewer who has higher authority to merge changes will click the merge pull request here. And once again, a confirmation command button is presented, and the reviewer will, probably the team lead, will click on the confirm merge, and the changes will be merged. So now let us go back to the repository, and you can see the change made is present here. And then you can also click here to see all the branches. So the branch 2 is what we just created. So now there is no reason to keep this branch because the change you made under this branch is already merged into the main branch. So you can go and delete these additional branches. I think it's a good idea to delete these branches automatically as well, because when you do the merging, there is an option for you. You can not only merge the change but also delete the temporary branch. So now with this, we learned how to create a branch and how to make a change under the branch and then commit it and then push it back into the GitHub repository, and then create a pull request for reviewers to get in and review your changes. And if successfully reviewed, the changes can be merged into the main branch. So now let us understand more about this branching and so on. So now this diagram shows what we did so far partially, and this diagram has quite a few other things as well. Let us talk about them. So we started with a repository, and then we created branches, and then we checked in our changes, and the changes were then later merged into the master branch, and the temporary branch can be deleted as I described. So now, is this the only purpose of branch? The answer is no. So here's what we did a few minutes ago. We started with a master branch, and then we created a temporary feature branch, and then we made some changes and then got it reviewed as well, and then it got merged into the master branch. So now there are other uses of creating a branch. Let us say, for example, the source code is ready for release, and you can create a new branch out of it and then call it as a release branch. And it will never be merged back into master, because on master branch you want to proceed, or your team wants to proceed towards releasing the second release. When the software is ready for release, a new branch can be created from the master branch, and it can be called as release 1 branch. And this release 1 branch will never be merged with the master branch. It will live on its own, and the release will be generated or built from this branch and delivered to customers. So customers will use the code out of this release 1 branch. After few months, or whenever you are ready for the next release, you will once again cut another release branch, and then it will never be merged with the master branch, and it will be on its own. So this is another way of using the branch. So these branches can never be deleted and should not get deleted. And this diagram also shows a few things. For example, customers using release 1 branch find a bug that you could not find it before releasing it. So a change will be made to the release 1 branch, and that change is so meaningful, it has to be picked and pushed into the master branch as well, because future releases should contain that fix as well. And alternatively, the other way around, let us say after releasing the release 1 branch or release 1 release, while working on the next version of master with the master branch, you find a bug that you should have found before releasing the release 1. Anyway, a new bug was found, and it was fixed in the master branch that you would like to be included in the release 1 branch for customers who are already using release 1 branch. So these two things can be done with cherry picks. So cherry pick is something that we're going to see later in this video. You can pick a specific commit from either release 1 branch and put it in master branch, or pick it up from the master branch and push it into any other branch, like release 1 branch in this case, and then rebuild the software and then deliver it to customers. So now let us talk about remote. Let me do this. Let me log off from the GitHub and log into another account. Now let me log into GitHub again. With entirely different account. Okay, I'm logged in. I'm going to create a repository here in this account. There are no repositories in this account at all. So let me create one. Forkable repo. I named it as forkable repo because I'm going to fork this repository into my other GitHub account. Okay, I'm done. Now let me create a file in this GitHub repository. So I'm going to create a new file, and I'm going to call it as demonstration. And I'm going to commit it as well. Okay, done. So now let me log off from this GitHub account and let me log in with the previous account. have turned on two-phase authentication, so it's asking me for the authentication code, and I got one, and I'm going to key it in. Okay, I'm in. So now what I'm going to do is I'm going to switch over to the other repository, even though I'm logged in to my original account. Okay, I'm in the other account repository, and I'm going to click on this forkable repo, and this is the repository I would like to fork into my account. But before I do that, why am I doing this? In open source GitHub usage, you cannot check in your files changes directly into the open source repository, because as I mentioned it at the beginning of this video, that there are numerous number of team members working on these projects, and they do not want anyone to introduce unnecessary bugs or unnecessary issues. So the methodology used here is fork the open source repository into your account, and then clone it into your workspace, and then do whatever you want. You create a file, you modify a file, fix a bug, introduce a new feature, whatever. And then you add that file to the staging area, and then commit it, and then push it. And when you do push, it will go and create the notifications in both your repository as well as the original forked repository as well. So in that case, you go directly to the original repository. Maybe one of your reviewers will do that, and they will create a pull request. They will probably, or you will create a pull request if you have access to, and review the code changes and merge it. So when you do that, the merged code will go directly into the original open source repository. So that's exactly what we are trying to do here, kind of a simulation of that. So I am in the forkable repo under SRID travel account, and I already pulled the repository, and I'm going to click on this link, the fork link at the top right hand side. Remember, I'm logged in as my original account, Get Sridhar, and SRID travel is like open source account, or a forkable repo is an open source repository. So let me click on fork, and it is asking me for where the changes should go to. It should go to Get Sridhar. That is where I'm logged in right now, and the forking is going on at this point. So now it is done. So now I have a copy of this forkable repo from the original SRID travel account, and it is mentioned at the very bottom of this title as well, so from where this is forked. So now what I'm going to do is going to clone this repository into my workspace, and then make some changes, add them to the staging area, commit, and then push, and then see what happens. After forking and cloning the repository, now I'm ready to make some changes to it, and then push the changes to the original repository, the other account repository directly. So first of all, I need to create a branch. New feature. Let's spell it properly. And the new feature is ready. Let me look at the Git branches. Git branch. So new feature is the branch that is ready on this environment. The other branch that you are seeing, the new change, was created for something else, and the main is the master branch. So under this new feature, I'm going to make a change to the file. and let me copy and let me write and quit. Now let me do the git add and say git status. Now the file got added to the staging area, and then let me do a git commit. New feature title. This is a new feature. So now it is time to push. I do not want to push this change to my repository, but I would like to push it to the upstream, the original repository directly. So to do that, I need to add a remote command. So let me see if I can paste it here. So this is how you create a remote to a repository. So this is the repository, the github.com srd travel forkable repo.git. This is from where I forked this repository in the first place. So it's done. So git remote -v should show both origin and upstream repositories. Now it is time for me to push this change to the upstream, that is the original repository. So git push upstream and then new feature. That is the name of the branch I'm in. So this branch new feature is not on the original repository, but it will be created when I do this. Let me key in the ID and password for the other account. Now it is going through. So now I need to go to this URL, https github.com srd travel forkable repo pull new feature to create a pull request. And this pull request can be created by me, but it will be reviewed by the owners or the leaders of this other repository, the srd travel forkable repo repository. So let's see how that is done. So now I am in the other account, the srd travel account, and you can see a message waiting for me. New feature had recently pushed less than a minute ago, a change. So let me click on compare and pull request, and it is showing me the title and the description I keyed in when I committed this change, and say create pull request. So now the pull request is created. It will show up under the pull request section. Now I can add some reviewers, and those reviewers can come and take a look at this change. And if they are happy, then they can merge the pull request by clicking on merge pull request and click on the confirm merge as well. Now it is done. Now if we go back to the code and look at this demonstration, I can see the change that I added. So with this, the code is now updated in the original repository itself. So now let's recap. We found how to clone, and we learned about branch, and we learned about add files to the staging area and commit, and pushing changes back to the GitHub repository. And we also learned about fork, and we also learned a lot about remote, and we learned about status and also pull request. So now it's time to focus on pull, merge, rebase, and fetch. So what is pull? Pull is pulling changes from the GitHub repository into your local repository. Say you cloned a repository, and after that somebody changed some code directly on the on the repository on GitHub, or some other developer or other team member made a change and then pushed their changes onto the repository, and then now you want to pull that change into yours local repository. Merge is merging changes between two branches, even across remotes. Rebase is an interesting concept. Say you have a master branch and then you created a branch out of it at some point of time. While you are working on your branch, you made some changes to the master branch, either intentionally or by the operation of pull. And the pointer, the base pointer of your branch is now pointing to an older level. So you need to move the base pointer of your branch to the latest level of the branch, of the master branch. So rebase will help you to do that. So we're going to see how to do that. And fetch is fetching files from the GitHub repository. In fact, pull is equivalent to fetch and merge. So let's see how these things are meaningfully explained. So in this diagram, I'm showing you how the source code gets forked from upstream to forked downstream. We already did this in the last exercise. And then we also cloned the forked downstream into a cloned repository on your workstation. We already saw this as well. And then we made some changes. We created a new branch on the cloned repository called feature branch, and then we made some changes to it. And then we pushed it back to the upstream. So now, let us say, for example, while you are working on the feature branch, somebody made some changes to the upstream branch, upstream repository. How to bring that into the forked work stream and also into the master branch of your cloned repository and also onto your feature branch as well, so that the code in feature branch is synchronized with the latest code from the upstream. So to do that, while you are in the feature branch, do a git fetch all prone. So this will not only bring in the changes from the upstream remote, but also from forked downstream remote as well. So for example, even though you own the forked downstream and you cloned it and then you made a branch called feature branch, there is a possibility that some more code changes would have gone in to the forked downstream as well. So bring in all those changes into the local workspace with the git fetch all prone. The prone will help you to remove any unnecessary, unwanted code that has been removed from upstream or forked downstream repositories. And then you switch over to the master branch with git checkout master all on your cloned repository. And then you merge the upstream master into your master branch of the cloned repository. So when you do this, this will help you to synchronize the changes coming from the upstream repository into your cloned repository. And then you do a git push origin master that will help to push the changes back into your forked downstream as well, because the changes from the upstream needs to go into the forked downstream as well. So with the help of these 4 commands, you can accomplish that. And the diagram on the bottom right side will be the result of all these operations. The git checkout feature branch, and then you need to do a git rebase of the master to the feature branch. So this is what I was talking about at the earlier stage. What if you created a feature branch out of master branch, and then some changes have already creeped into the master branch of the cloned repository? How to move the base pointer of your feature branch to the latest level? That is done with the git rebase command. So, but there is an alternate method. Instead of doing all these 6 different commands, you can do the whole thing in 3 commands. The git checkout feature branch, and then you do git fetch upstream and then prune it, and then you do a git rebase, and that will do the same thing as well. Now let's see what is cherry pick. Cherry pick is to pick a specific commit from another branch somewhere into your branch. So to do that, let me create a new branch and then make a change and then push it, and then try to cherry pick that into another branch. Okay, let me try to create a branch here. New cherry branch, and then git branch shows my latest branch as current branch as new cherry branch, and then let me make a change. This is a cherry, and then as usual let me do git add and then git commit. Okay, now I'm going to push it. Going to ask me for the user ID and password again. Okay, so this is all set, and I need to go and merge this change. So these are the changes. So let me merge all of them. Looks like some additional changes came into this branch while we were working. What you're seeing now is somewhat complicated commit clashes. So let's not worry about these for now. So all these pull requests got merged. And now let me process the newly added pull request. And there is a problem here as well. Let me resolve all these things. Okay, all set. So now back into this command line. The new cherry branch just committed and pushed a change, and I need to know the commit ID. So let me introduce another command called git log. This git log command will show all the changes that have taken place in the current branch. So as you can see, these are the changes that took place from the beginning till the end. The latest one is on the top, and this is the cherry pick work that we did. And here is the commit ID. So let me copy this commit ID safely to the clipboard. And now I want to switch branch, say to new feature. And now I am in the new feature branch, and if I look at the demonstration file, the cherry line is not there. So our intention is to bring in this change from the other branch into this one. So now let me try git cherry pick and the commit ID. Let's see what happens. There's a merge conflict. So how do we resolve it? Let us do git status. And the file has been modified already. And here is the problem. The merge conflict is something that I would like to address in a separate video. But the problem here is in the same file, the git command or the git cherry pick is not able to figure out where to add this is a cherry line. Should it add it here or should it add it here? So it is for us to understand this new cherry picked code and place it in the appropriate position. Sometimes the git cherry pick or git merge commands will automatically take care of these things, but sometimes they don't. So I need to delete this line and delete this line and delete this line as well. And to my understanding, this is how it should be. The code that is coming in from the cherry picked should be at the end of this file. That is the determination that I had to make. And if I'm satisfied with that determination, then save it and quit. So now I need to do git add and then git commit. Or I can do git cherry pick continue. And it is presenting me with the same information I keyed in when I created that commit, the cherry pickable commit earlier. And let me save it, and it is done. Now if I do git status, everything is clean, but I still need to push this back if I want this to be permanent. Git push origin. Keep forgetting the branch names. So new feature. Git push origin new feature. So now it is gone. So this is how you pick a particular commit from another branch, either local or remote, doesn't matter, and then bring it into your branch. This is very, very helpful tool, particularly in the support organization. They do this a lot. Say a particular release was released and customers were using it and they found a problem and it was fixed in that release branch. So now that particular fix needs to be picked up and applied to the master branch that is still under development for the next release. Things like that. Or if there is another release that is already out, and if a fix has to be copied from one release branch to the other release branch, cherry pick can be used very effectively. But you have to understand your code a lot, because in the case of any merge conflicts, you need to know what to do, and how to handle the situation. And also the cherry picks, even if it goes through, will blindly insert code copied from somewhere else. It will try to do a good job, but you have to pay attention to the changes. You have to look into the changes after the cherry pick and then make sure your intentions are clear and the cherry picked code is properly copied from one area to the other area, from one branch to the other branch. So you have to pay attention a lot. This is where the unit testing plays a significant role. So now I think we need to do one more to complete this video, and that is git diff. So let me do this git status. Everything is clean, and let me make a change. Let me create a new branch, git checkout. Diff branch. I am in the diff branch right now, and I want to make some changes somewhere in the middle. So like that I will make many changes, and I want to know what all the files I modified, so I can use this git diff command to see the difference. So the git diff command is equivalent to the diff command in Linux, and it tells me which particular line, into which particular line a new change has taken place. It's a very handy tool to figure out what you changed. So now let us see if the git diff can be executed at various stages. Git add dot git status. The file is in the staged area. Let me try git diff command here. I don't see it. So that means the git diff will work only until you stage the files. Once you stage a file, you cannot see any differences. There could be some ways to do it. Maybe there's a cache parameter that you can pass that I will figure out, and then I will let you know in a separate video. But once you stage a file, git diff will not show the changes. Now let's talk about git tag, the tagging of the particular checkpoint. So tagging helps you to figure out how many checkpoints have happened in the master branch particularly. So I checked out the master branch, the main branch. Now I'm going to tag this particular point, checkpoint in this main branch with a string called v1.0 whatever. So git tag v1.0. Either I can do this, or I can say -a v1.0 and then -m. This is the first release. So the first technique, the git tag and then a string, the v1.0, is called lightweight tagging, and this one is called annotated tagging. So let's do annotated tagging. Done. And now if I do git tag, it will show you the version. And I can also do git show, and that will tell me the changes that have taken place recently that I pushed to the upstream. And if I include the tag to the git show, then it is going to show me everything that is related to this particular checkpoint, whatever that has gone into this particular branch. So it's very easy to understand how and where the tagging has taken place. So if you look at it, the git annotated tagging created an entry like this. This is the first release, and then who made it at what time, and so on. If you do a lightweighted tagging, this will not happen. So annotated is something that is preferred. So now let us go ahead and then create another branch and then push, or we can push the change directly from the master. So let me show you how to do that. Okay. Branch. We are in the main branch. So let me modify the demonstration file. This is not preferred, but let me show it to you anyway. You always create a branch and then go through pull requests and so on. But this is, you can do it directly on the master branch. And then do git add dot, git commit, and then git push. So if you work directly on the main branch or the master branch, you don't have to go through the pull request, reviews, and whatever. It will get updated straight away. So now we have made a change. Now let us create another tag. Let us call this as version 2.0. Let me go back in the history. I'm going to say this is my second release. So now if I do git tag, there are two releases, and if I say git tag, show v1.0, it will show whatever that is taking place until the first release. And if I do 2.0, it will show me the changes that took place after the first release and until now, the second release, until second release is tagged. So this is yet another very important aspect of GitHub that is very, very useful for long-term software development. This shows GitHub is very mature and it's got all kinds of bells and whistles to do software development at a very high level. No wonder enterprises use GitHub for source code management. So now I would like to end this presentation with a recap. So let's go back to the chart. So we started with clone. Before that, we created the repository on the GitHub account, and we could do it either through the browser or through the command line as well. And then we understood the status, the git status command. We have been using the git status command quite a lot in this presentation. And add files. So after making changes, we could add files to the staging area. And then commit is to commit these changes so that they can be pushed. And then we learned how to push the changes to the GitHub account. And then we learned about branching. There are two different purposes for creating branches. One is to do temporary work and then merging it back into the master or main branch. The second one is to create release branches and keep them permanently away from the master branch or main branch. And then we talked a little bit about the release branches. And then we talked about remote. The idea behind the remote is to maintain pointers to two different or two or more repositories, and we can borrow code from one of them and so on. And then we talked about pull. Pull is just like fetch and merge. And we talked about rebase while working on one of the examples. And we found out how to do cherry picks from one branch to the other across remotes if required. And we also talked about merge using that example. And we looked at log, git log, and we also looked at git diff, and we also looked into the git tag, and we also did this fetch, and we went through this exercise of how to fork from one repository to the other repository. I want to mention at this point that I was kept on keying in the user ID and password. You can avoid that by copying the SSH public key to the GitHub online account. So if you share your public account, then you do not have to key in your user ID and password when you do a git push. And we did all these. And then pull request, of course, we created a pull request for review, and then merge out of pull request into the main branch or master branch. So that's it. So I hope you enjoyed this presentation about Git. And if you are very new to Git, probably this would have helped you to start working on it straight away. Everything is free. You don't have to pay for anything. And it is very valuable skill to have if you want to work on software development these days. Without an understanding of Git, it will be impossible to do anything in software development. And I hope you enjoyed this video, and in another video very soon I will meet you on another topic. Thanks for watching, and bye for now.